minus 12. 12 minus 12 will cancel. Therefore, f of g of x is equal to x. Therefore, f of g of x is equal to x. That's the test. So let's see if g of f of x, if it's going to pass the test also. So we are going to put in g of f of x. All right, so I'm going to tidy up some stuff here. Do some cleaning. Okay, and then I will find g of f of x. If it is equal to x, then the two functions are inverses of each other. All right, so g of f of x. So I'll bring down g. So now there is an x over 2. And that place where x is, I'll substitute f. So 2x minus 12. Wherever I see x, I substitute f. All right. And then look at g. I still have 6 there plus 6. If I divide through in this, I have x minus 6. Then bring down 6 here. Minus 6 and 6 will cancel. Therefore, g of f of x, g of f of x is equal to x also. Because the g of f of x and f of g of x are equal to the same number, x, even though x is a variable for this one, then they are inverses of each other. They are inverses of each other. Okay, so now we have proved that the functions g of x and f of x in number 1 are inverses of each other. All right, so we are not going to be wasting so much time because we already know how to do g of f and f of x. One more thing about inverse before we go to exponential function. So what we have today, exponential function and logarithmic function. We are using this to introduce exponential and logarithmic function. All right, so let's go to one linear equation that we did. Can we find the inverse of linear? Every linear equation has an inverse. For example, the one here, if I draw it, this is a straight line. The leading coefficient of x is 3. In other words, the slope is 3. Therefore, if I draw the graph, it's a straight line, which means it will surely have passed the horizontal line test. It will pass both vertical and horizontal line test. It will pass vertical line test and it will pass horizontal line test. So it is a function, but I can be told to find the inverse. Remember, you did it somewhere in Algebra 1, Algebra 2, somewhere. But this is just a reminder. I just want to remind you this so we can use it to get into exponential functions. Okay, so when I am given y equal to 3x minus 6, the first thing I want to do is exchange the values of x and y. I'm looking for the inverse of the equation. So wherever I see x, I write y, I write x. Wherever I see y, I write change x with y. Bring down negative 6. Then solve for y. So I'm solving for y. So I add 6 on both sides. Let me finish it up on the right hand side here. And so I have x plus 6 is equal to 3y. Divide both sides by 3. So now I have y is equal to x plus 6 over 3. So now I have the inverse. I already know that this function has an inverse, so I found it. But now I'm not going to write this as y. I will now write it as f inverse of x. So f inverse of x is x plus 6 over 3. We already know that every linear equation has an inverse. We could be told to find the inverse. That's what we just found. So we found the inverse of that function. All right, so we will quickly talk about exponential functions. And exponential functions, let's get to the PowerPoint. We're going to PowerPoint 6.1. So PowerPoint 6.1 is where we are going right now. This is 6.4. So we are going to PowerPoint 6.2. Unit 3 is all about chapter 6. All right, so this time I'm going to 6.2. So we are looking for x inverse. We already talked about inverse. And so we will not waste time because we still have a test next week. We get the things that are very important and we talk about it. So we want to make sure we remember the properties of an inverse. Remember, come on, go back. All right, properties of inverse. Addition properties, subtraction properties. So for any real number, a greater than 0 and a not equal to 0, the following statements. We already know this. A to power x. If I raise any number to power x, it's a unique real number for each real number x. So if b is equal to c, for example, suppose I have 3, well, 3 is equal to 3. And if a is 2 to the power 3 is equal to 2 to the power 3, and so on. So we're going to see all the properties of exponents we already know. So if m is less than n, I just want to show you this so that when you go home, you look at them. So when we write a function like this, where the base, if the base, a or b, whatever they call it, if the base is greater than 0 and base is not equal to 1, then f of x is equal to a to the power x is called an exponential function. I can write it this way also. F of x is equal to b to the power x, where b is a real number. B cannot be equal to 1, and b must be greater than 0. The base of an exponential function must be greater than 0, and must not, greater than 0 means it cannot be negative, and it cannot be 1. For example, you know that if b is 1, then any number raised to the power 1 to the power 100 is still going to be 1. So b is not allowed to be 1 to the power 1000 is still going to be 1. So the base of an exponential function is not allowed to be 1. Okay, that's all they are saying there. And then we will be told to graph an exponential function. So I'm going to pull up my calculator, even though already you can make a table of value to graph this function. We are going to graph another one by ourselves. We're going to graph another one. So let's draw an exponential function. Let me grab my calculator And then we shall also graph it by hand. So I'm going to get my calculator right here. I'm going to clear my y equals whatever is in there. Let's get an exponential function and try to graph it. So I'm just going to grab one as an exponential, make it up. I'm going to make it up. So let f of x equal to 3 to power x. You notice that the base is greater than 1. The base cannot be less than 0. The base of an exponential function cannot be less than 0. It cannot be negative, and it cannot be equal to 1. Okay, so if the base, let's call b, if b is greater than 1, then it's an exponential growth. Let's call it exponential growth. So that we start now, exponential growth. Okay, so let me quickly put this in my calculator, and so we see what an exponential growth is. And we can also quickly put it, make a sketch, make a table of value for that. So what is, how do I grab that if I'm told to sketch it by hand? I could be told to sketch it by hand. All right, so I will make a sketch. But before I make a sketch, I would like to make a table of value. So just make a table of value so that it will be clear. Okay. And this is my x. This is my f of x. Okay. Let me start picking the values. We already know that x can be 1, but b cannot be 1. So let me pick 0. If I pick 0, when x equals to 0, 3 to the power 0 is 1. 3 to the power 0, any number raised to the power 0 is 1. That's what is properties of exponents. When x is, let me use, I'll be use 2. When x is 2, 3 squared is 9. When x is 3, 3 times 3, 3 to the power 3 is 27. So I'm going to make a sketch. So let me make a sketch of this graph. And the highest y value is 27. So I can actually make 10, 20, 30. Because the highest y value is 27. I'm going to extend this one also. All right, so this is 0, and I will use 1, 2, 3. Okay, and when x is 0, y is 1. So that means every exponential function cannot, so 1 is somewhere here. 1 is somewhere here. Where is my, okay, just put it back. 1 is somewhere here. When x is 0, y is 1. When x is 2, y is 9, somewhere here. This is 20. It's 9. When x is 3, y is 27. All right, and then if I pick another number, when x is negative 1, x can be negative, but the base cannot. If x is negative 1, then y is 1/3. So somewhere here. And I want to connect the points. So you notice that the graph is rising exponentially. And I want us to know that this, at any point on this graph, the slope is increasing. At any point on this graph, the slope is positive. At any point on the graph, the slope is positive. Notice that we call it exponential growth because it is growing exponentially. Okay, we're going to see an example here. So this is an exponential growth. It's always increasing. It increases throughout its domain. The domain of this function is from negative infinity to positive infinity. And the range will be from, it doesn't actually touch zero. We're going to say from 1 to positive infinity. Okay, well, so let's find B. B can be between 0 and 1, but B cannot be 0 and B cannot be 1. So suppose the base is between 0 and 1. So let's get another, maybe we can do it on the same graph. So I am actually going to find the inverse, or find a B. Suppose B is equal to 1/3. In other words, I can rewrite this as, let me write it, f of x is equal to 1/3 all to power x. Well, note that this can also be written as f of x equal to 3 to power negative x. Yes. Okay, so they are the same. F of x equal to 1/3x to power x, or this. And this means that b is between 0 and 1. And whenever b is between 0 and 1, it is an exponential decay. Okay, so we can make a sketch quickly. We can make a sketch of an exponential decay with our calculator. Or we can do a calculator. So let's make a sketch of an exponential decay. So the function is f of x is equal to 1/3 all to power x. All right, so let me make a sketch. And we want to see how this graph is going to, this is x, this is my f of x. Okay, so when x, I know that this graph will be leaning to the left. So let me start from 0, or I can start from 1. When x is 1, I substitute 1 here. 1/3 to power 1 is 1/3. When x is 0, 1/3 to power 1 is 1/3. When x is 0, 1/3 to power 0 is 1, because anything raised to power 0 is 1. All right, so let's make, when x is 3, do I want to use 3? Let me use 2. 0, 1. Okay, let me make it 1. -1 this time. -1. All right, so let's look at that. When x is -1, then I want us to know that this function is the same as 3 to power -x. So if x is -1, then I have 3 to power -1. In other words, x is, then I have x is going to be 1/3. Okay, so 1/3. Let me see if I did some stuff here. Okay, so I will have 1/3. Then I have 1 over 3. Actually, then I have 3. No, 1 over 3, sorry. Okay, I'm going to, negative 1 is going to be 3. So let's draw the graph on the left-hand side. So I'm going to make a sketch of this graph on the left-hand side. And I have the values of x as 1, 0, -1. And the points I have is 1, 1/3. So let me just make this one 1, 2, 3. When x is 1, I have 1/3. 1/3 is somewhere here. When x is 0, I have 1. X is 1, I have, when x is 0, I have 1. When x is -1, somewhere here, I have 3. And if I pick another point here, you notice that it is going nearer and nearer to x-axis. So let me connect the two graphs, 2 points. I'm connecting the points. I can continue. So this is the sketch. It's a rough sketch. Okay, and then this is the graph of f of x equal to 1/3 x, or 3 to the power -x. Well, let's see. This curve is decreasing throughout its domain. So this is called an exponential decay. This is an exponential decay. Exponential decay. Why? Exponential decay. D-E-C-A-Y. An exponential decay. Because at any point on this graph, the slope is negative. So it's decreasing throughout its domain. It is decreasing throughout its domain. The slope, the domain is all real numbers, and the range is still from, okay, so what are we just saying? We meet an exponential decay whenever the base of an exponential function is between 0 and 1. If the base is between 0 and 1, if the base is between 0 and 1 base, so we have exponential decay. Exponential decay when the base is between 0 and 1. Okay, so I can just say it's less than b, and when 0 is less than b and b is less than 1, the function is an exponential decay. We can put it in a calculator quickly and we see, and we will also be finding the inverse. So that is so far about exponential growth and decay. Okay, we shall be actually given functions. The exponential growth and decay, actually exponential function and logarithmic function are inverses of each other. They are inverses of each other. So if I write f of x is equal to x, 2 to the power x, and I want to change it, I'm going to write y here. So I will change f of x to y. So y is equal to 2 to the power x. Well, remember that anytime I'm told to change, find the inverse, so this is an exponential function. If I graph it, I will get a function increasing to the right. Well, if I want to find the logarithmic function, I will switch the function. So I will now have x is equal to 2 to the power y. If I graph this function, it is a logarithmic function. Okay, if I graph this function, it's a logarithmic function. All right, by the way, let's quickly go and find out how can I convert numbers from exponential. So I want us to remember that 8 can be written as 2 times 2 times 2. In other words, 8 can be written as 2 to power 3. So this is an exponential form. Since this is an exponential form, exponential functions are inverses of each other. Exponential functions and logarithmic functions are inverses of each other. So I can rewrite this in logarithmic form also. The base of exponential function is still going to be the base of the logarithmic function. So I will write log to the base. What is the base? 2 of 8 to base 2 is equal to 3. Another way of saying is if I multiply 2 by itself 3 times, I'll get 8. Just what we do here. If I multiply 2 by itself 3 times, I'll get 8. So let's get another one. Let's get another one. All right. All right, so let's get to 3. I'll continue with 2. 16 is equal to 2 times 2 times 2 times 2. So I can say that 16 is equal to 2 to the power 4. I can write this. This is now exponential form. I can write the exponential form to logarithmic form. So log, and when I write log, it is called common logarithm. So log of 16 to base 2, the base of the exponential function is the base of the logarithmic function. It's equal to 4. That means if I multiply 2 by itself 4 times, I will get 16. Multiply 2 by itself 4 times, I will get 16. If I want to find it, check it back, I can convert it back to exponential. So that means I can say 2 raised to the power 4 is equal to 16. All right. So exponential function and logarithmic function can be used intermittently because they are inverses of each other. Okay, so let's quickly use this. Use this to solve some few problems because we now know that we can convert an exponential function to logarithmic function, and from logarithmic to exponential function, we can solve some problems. Okay. Now we want to solve some problems. Let's get to simple ones first. Let's get to some problems that will not take us too far. All right. So we want to find actually where I should be is in homework 6.2. So let's go to homework 6.2. Homework 6.2. All right. So homework 6.2, let's go there and see. And we will find some problems we can solve. This is graphing for now. Okay. So this is what we're talking about. We're going to be told to solve a problem like this. So 16 to power x is equal to 4. We already talked about this. If the bases are equal, the exponents are equal. If the bases are equal, the exponents are equal. So what I'm going to do is there any way I can raised 16 to the same base as 4. Yes, I can write 4 times 4 is 16. 4 times 4. So 4 squared is equal to 4. 2 to 2x, and this is 1. And actually, I can solve it like this. So 2x is equal to 1. Therefore, x is equal to 1 over 2. And by the way, I know that I can actually still simplify this. So I have 2 raised to power 4x is equal to 2 raised to power 2. But still, the bases are equal, the exponents are equal. So 4x is equal to 2, and x is still equal to 1/2. So even if you simplify it to the lowest, you will still get the answer. Okay, so we aren't going to use calculator yet. So we are going to be graphing. So let's graph this translation. I just want us to know, let's put our calculator, let's put E. What is E? The base can be E. Okay, the base can be E. So, and E, let's remind ourselves what E is. E is exponential function, and what is it? So second E, this is E, and then I'm going to put this to power 1. What is E to power 1? 2.72 to 2 decimal places. So E is 2.72, which means the base can be E. So suppose I am given the function f of x is equal to e raised to power x. So this is an exponential growth because e is greater than 1. So that function is an exponential growth because e is greater than 1. It can also be an exponential growth. Okay, so we have, let's go back to that. Let's go back to, and so if I have this function, there are transformations. We can do some transformations here also. So if I graph the function e to power x, I have something like this. If I graph the function e to power x minus 3, it moves to the right by 3. So it's a horizontal translation. So I have a horizontal translation. You can put that in your calculator and see. If you're told to graph it, you will put it in your calculator, but you will have a horizontal translation. And when you look at your graph, you find the domain and the range. All right, so there are stuff we can do without. Now let's solve these exponential functions. Let's go to number 10. Number 10 is 4 to the power x minus 7 is equal to 256. And then we can find the factors of 256, see if there's any way we can make it 4. We don't really have to use a calculator all the time. So we can still remember the $3. I mean, well, we don't call it $3. The number 3 we used in primary school. So I don't know if you called it number 3, but we did call it number 3. If I divide by 2, this number by 2, so I'm going to see that I have 1. If I divide 5 by 2, I got 2. If I divide by 16, I got 128. If I divide by, I don't know if you called it factor 3 or number 3, whatever you called it. If I divide 128 by 2, I get 64. If I divide 64 by 2, I had 32. If I divide 32 by 2, I have 16. If I divide 16 by 2, if I divide 16 by 2, I have 8. If I divide 8 by 2, I have 4. If I divide 4 by 2, I have 2, 2. Okay, according to number 3, all I need to do to get the factors is count all the 2's. 1, 2, 3, 4, 5, 6, 7, 8. Okay, therefore, let me see if that's all of them. So therefore, I can now say 4 raised to power x minus 7. I can put this as 2 raised to power 2 into x minus 7. Then we can count this again in case we forget. So 1, 2, 3, 4, 5, 6, 7, 8. So then I have 2 raised to power 8. So we use factor 3 or number 3, whatever you called it, to find that 256 is the same as 2 to the power 8. The most important thing is the bases are equal. When the bases on the left-hand side and on the right-hand side are equal, then the exponents are equal. So if I can make the bases equal, then the exponents are equal. So now if I distribute here, I can just bring it down. 2 into x minus 7 is equal to 2 to the power 8. So I can open the parentheses. I have 2x minus 14. And I want us to know that this is 8 actually. So I need to put 8 here, 8. The bases are equal, therefore the exponents are equal. The bases are equal, so the exponents are equal. Collect like terms and solve for x. 2x is equal to, I'm going to add 14 on both sides. So 2x is equal to 22. So 2x is equal to 22. Therefore, x is equal to 11. So whenever we are given exponential functions to solve, we can use that. So x is equal to 11. That's number 10. We're going to do number 11. So whenever we have exponential functions, we can solve it this way, provided that I can find a common base. If I cannot, then we shall do the inverse of, because exponential function is an inverse of logarithmic function, then we can take log of both sides. All right, so, okay, so now let's go over number 11. This is homework 6.2. So homework for tonight, 6.2. I'm starting it and then you will finish up. Okay, so let's see, how do we solve this one? Is there a way I can make the basis? The base on the right is 1. The base on the left is 7. Yes, there is a way. We know that anything raised to the power 0 is 1. So we can say 7 to the power x minus 9 is equal to 7 to the power 0. Because anything raised to the power 0 is 1. The bases are equal now, so the exponents are equal. X minus 9 is equal to 0. Therefore, x is equal to 9 should be our answer. You can check your answer. This also we can solve without any problem. All right, so let's solve that without. And then here we have, is there a way? Yes, 81 will have factors of 3. I can use my factor 3 again. So I can use my factor 3 to find all the factors. But I already know that 3 times 3 times 3 is 27. So the left-hand side should be 3 to the power 4. 3 to the power 4 multiplied by x, 3x is equal to 3 to the power 3 multiply x plus 2 minus 2. Actually, it's plus. Okay, and so we can okay, so we open the parentheses and I have 3x and I have 3 to, if I multiply in, I have 12x is equal to 3x, 3 to the power 3x plus 6. The most important thing is that the bases are equal. So the exponents are equal. Now I am going to collect the exponents and solve. The bases are equal, so the exponents are equal. So 12x is equal to 3x plus 6 minus 6 on both sides. And this cancels. Actually, I can just leave 6. I can just leave 6 here. Okay, that's fine. And then I will do let me leave 6 on the right hand side. That way it will not. Okay, so minus 3x is what I want to move. Minus 3x on both sides. And so this goes, so I have 9x is equal to 6. 9x is equal to 6. Therefore, x is equal to 6 over 9 or 2 over 3. 6 over 9 or 2 over 3. All right, so that is my answer to the question. Okay, and then we can go to the properties of logarithm also, and then see the laws of logarithm. Yeah, we want to see the laws of logarithms. That I think you can finish 6.1 worksheet. So let's go to 6.2. Now we did 6.1, 6.2. Let's go to 6.3 homework. So this time is 6.3 homework. I hope you know that you can rewrite this. You have to rewrite this. Square root of 2 is the same as 2 to the power 1/2. So it's going to be 2 to the power 1/2. 2 to the power 1/2 parenthesis x plus 7. On the left-hand side is equal to, on the right-hand side, you have 4, so you can make them, they have the same base, so you can solve. If the bases are equal, the exponents are equal, then you can finish solving that. So that's homework for tonight. Okay, let's go for homework for, well, we see how it's going to be for tonight, though. So we're going to homework 6.3. Do you have any question?
I do. Hi.
Okay.
I was wondering if you were going to post the PowerPoints in the Unit 3, because all there is the practice test. And I noticed that the practice test that I printed out to follow along does not match what is on the screen right now. It's all
okay.
I'm
going to look. Okay, I will look at it.
Thank you.
But by the way, these practice tests are the same. They are the same skills. So okay, by the way, let me look at it now. It's okay. Let me look at it because I'll look at that practice test now because it's important that they match. If they don't match, I will change it. So let's go there. Let's go there right now because you need to have the right thing. Okay, so then I'm going